When you hear 3D printing, your mind probably jumps to little plastic toys, right? Or maybe some crazy industrial parts. But what if I told you its biggest revolution is happening somewhere you'd never expect? Inside your mouth. Yeah, today we're diving into how this tech is completely flipping the script on something millions of people rely on every single day: dentures. All right, so let's get right into it. The big question we're tackling today is, how do you actually engineer the perfect denture in the 21st century? Because we're not just talking about a simple replacement for teeth anymore. We're talking about a custom fit, high performance medical device that has to be, well, perfect. So, to really appreciate just how big a leap this is, you got to look at how things used to be done. Let's talk about the next generation of dentures. Okay, so the old way of making dentures, it was a real art form, right? A true craft. It involved all these steps: mixing, molding, curing, all by hand. But the downside was it took forever, and everything depended on how skilled the technician was. It was just so easy for tiny little errors to creep in. But now, that's all getting thrown out the window. The new way is totally digital. We're talking about additive manufacturing, or 3D printing, and it brings speed, unbelievable accuracy, and something that's absolutely critical in medicine: consistency. You get the same perfect result every single time. But hold on a second. Here's where it gets interesting. It's not like printing a paper for school where you just hit print and you're good to go. No way. The thing that actually comes out of the printer, it's not finished, not even close. It needs one more super important step to be safe and to actually work. And that's what brings us to the secret sauce, really. The hidden science behind that perfect print, this thing called the crucial curing step. This is what turns a good printed denture into an amazing one. Okay, so this step is called post-curing. And the best way to think about it is like you're baking a cake. Seriously, the 3D printed denture is just the raw batter. I mean, it's got the right shape, but it's soft, it's not ready. Post-curing is the oven. It uses UV light to bake the denture. And that light forces all these tiny molecules to link up and form these super strong chains. This is what gives it its incredible strength and, just as important, makes it totally safe to have in your body. Right? But here's the thing: you can't just stick it under any old lamp. Sticking with our cake analogy, you know that every cake needs a specific temperature and the right amount of time in the oven, right? Well, it's the same deal here. Scientists had to figure out the perfect recipe of light, the exact combination of settings to get the absolute best, strongest, safest result. And how do you find that perfect recipe? Well, you run an experiment, a really cool experiment in light. This is where things get really scientific. Now take a look at the gear they used for this. This is not your average tanning bed lamp, okay? This is a custom-built, seriously high-tech curing chamber. It's got these LED arrays on all 6 sides. Why? To make sure that the denture gets hit with light perfectly evenly from every single angle. This setup gave the researchers total, precise control over every single variable. They played with two main things. First, 3 different wavelengths of UV light. You can think of that as like different colors or types of UV energy. And they tested those against 3 different light intensities, which is basically just how bright the light was. So 3 wavelengths times 3 intensities, that's 9 unique recipes they tested to find the absolute champion. And this here gives you a bird's eye view of the whole workflow. Super systematic. First, they 3D printed a bunch of identical samples. Then they cured each batch with one of those 9 light recipes. And finally, they put those samples through the ringer. A whole battery of tests measuring everything from how smooth the surface was to, and this is the important part, how strong and how safe they were. So, after all that meticulous work, what did they find? Well, after all that testing, one thing just screamed out from the data. The single most important factor, it wasn't the type of UV light. Nope. It was how intense it was. Just look at this chart. Along the bottom, you've got the light intensity, going from low to medium to high. And on the side, that's flexural strength, which is just a fancy way of saying how much you can bend something before it snaps. And you can see, no matter which wavelength they used, the pattern is exactly the same. The brighter the light, the stronger the material. It's a straight line up. So the main takeaway, the thing you really need to remember, is this: brighter light made a stronger denture. Simple as that. And this is a total game changer, because it makes the whole process so much simpler. Now, manufacturers can just focus on cranking up one main thing, the brightness, to get a way, way better denture. So, just how strong are we talking about here? The strongest sample they made hit 147.2 megapascals. Now, that number probably doesn't mean much to you, so let me put it in perspective. The international standard, the minimum requirement, is only 65 MPa. So, this optimized process creates a material that is more than twice as strong as it needs to be. That means it's incredibly durable. Okay, but being super strong is totally useless if the thing isn't safe to put in your mouth, right? And that's what we're looking at here. This is all about how human cells react to the material. On the left, you see a control sample. All that red, those are dead cells. That's what happens with the toxic material. But now look at the sample from the experiment on the right. It's a sea of green. Those are healthy, happy, thriving cells. This is the proof. Even at the highest, most intense light settings, the final denture was completely non-toxic and perfectly safe for the body. All right, so we've geeked out on the science, but let's bring it all back home. What does all this actually mean for you, for the patient? What's the most important finding for the person who's actually going to be wearing this thing every day? Well, it really boils down to three huge things. You get a better denture, and it's backed by some serious science. First, it's way more durable. Like we said, it's over twice as strong as the standard, which means it's just much, much less likely to break. Second, it's safer. This optimized curing process makes sure pretty much all of those raw, unreacted chemicals get locked in so the final product is super biocompatible. Less chance of any irritation. And finally, let's not forget, the whole 3D printing process is just a ton faster than the old school way of doing things. Don't just take my word for it. The researchers themselves wrapped it up perfectly. I'm quoting here. Light intensity was the primary factor influencing post-curing performance, suggesting that optimizing light parameters could enhance clinical reliability. So what they're saying in plain English is, by nailing this light recipe, manufacturers can make dentures that are just flat out more reliable for people in their day-to-day lives. You know, what's really exciting is that this research is bigger than just dentures. It's a roadmap, it's a blueprint for how to perfect other 3D printed medical devices. And that just makes you wonder, right? If we can apply this level of engineering to perfect a denture, what's next? Are we talking about custom surgical guides that are printed right before an operation? Personalized implants that fit perfectly? Maybe even scaffolds that help our own bodies regrow tissue? The possibilities here are just starting to open up.